So for today's video, it will pretty much be another Leetcode question, which is Leetcode 38 count and say. And once again, it's always nothing has been submitted, and this is a new question. And I was just going through my list of problems that I've not solved, and I chanced on this question, so I wanted to go about it. But the first thing I noticed about this question is if you can look, you can see there's a lot more dislikes than likes. And as I read through the question the first time, I noticed the reason why. So this is probably just saying a sequence. Content says sequence is a sequence of data strings defined by a recursive formula where count say of 1 equals 1, which is the base case, and count of say n would be the say data string from count and say n minus 1. So if they say count of say 4, it would be the say they get from, let's say, count and say 3. But to go on, if you look at the examples they did here, I think that's the reason why people disliked it, because it doesn't make sense at all. Let's say count and say 4. So they say count and say 1 is 1, count and say 2 is 1, so 1 say 1, which is 1 1, because there's only one digit here, so 1 1, so 1 1. So and then they say count and say 3 is should be count and say 2, and then they say it's 1 1, so like 2 1s, sure. And then they say count and say 4 is, because I thought count and say 4 would be count and say n minus 1, so count and say 3. But I think that's where the confusion comes. But to just make things simple for you guys, all they basically want you to do is, for count and say 4, just use the results of count and say 3. So if count and say 3 give you 2 1, that's what, see, 2 1, this is the 2 1 you would be using here to do it. So with 2 1, you know it's 1 2, and there's only 1 1. So that's why they say 1 2, which is 1 2, and 1 1, which is 1 2 1 1, which is 1 2 1 1. So basically, to do any count say n, I'm just gonna put it here in like hash. To do any count and say n, you have to do count and say n minus 1. So you have to do count and say, you have to get the results of whatever you got for count and say n minus 1. I'll say count and say n minus 1. So if they want you to do count and say 30, you have to get the results. That's whatever you got here of count and say 29. And then you put that one in there, and then you check as if you're saying it. So this one, for instance, in this example, it's 2 3s, 3 2s, 1 5, and 1 1. So that is pretty much it. But so that is what we have to do for today's code. But to do that, I think they give a hint that you should use recursion or whatever, but I don't think recursion is needed, because I think that's one reason why it confused a lot of people. So one way we can go about it is we can use I'll give you guys a couple of time to think about what we can do. But I think an obvious thing is what we can just do is whatever count and say n value we're given, we just keep calculating from count and say 1. I mean, we don't need to do count and say 1 because that's already a given. But we just need to do from count and say 1 to count and say dot n minus 1 and put that value into whatever n it is. Like, so even if we're giving count and say 100, we have to do from count and say 1 to count and say 99. Maybe that is not the most efficient way, but from how I look at the program already, or the for the question, you can do you cannot do any count and say of a certain n if you don't know the count of say of the n minus 1, and you can't do n minus 1 if you don't know n minus 2. So you have to anyway start from 1 and do it all the way to n minus 1, and then use n minus 1 to do n. So we always have to do everything from 1 up to n anyways. So basically, that's the first thing we have to do. So that's the first thing in mind. Now, to do each of them, as I said, from 1 to n, if we're doing each of them, let's say if we have 1, how do we know 1 should give us 1 1? How do we say just 1 1? Because there's only just one single 1, so 1 1. So what we can do is just use a hash map or a dictionary. So basically, we loop through the list, the string that we have, and we push it in a dictionary. So basically we can have something like a dictionary that just has this in Python. So we just read one string, so we have one here, and then it appears one. So basically, all we know is that now we can see that one appears one time. So we can just have that. So for instance, in this number given up here, we can have 3 that appears twice. We have comma 2 that appears 3 times, and then comma 5 that appears 1, and then comma 1 that appears 1. So in this case, we can see that all we have to do is now we just go through the list again, and all we do is we probably just keep a set of them. We just keep a set of this numbers here. So if we keep a set, it will just have 3, 2, 5, 1. We know that's what it will give us for sure. So all we will be left is just saying, hopefully depending on what we're given, but because we have an end of this and end of that, and however it works out, all we just need to do is we know that we probably don't even need to go through it like that, but we just need to um we just need to maybe go through the string again, and then so we see 3, and then we check what three's value is. So it will be like string of that, because we know these values here, even though these keys are strings, we know these keys are strings, we know that the values of each of these keys will be integers. So we need to convert all of them to strings as well. So it will probably just be string of that, and then you know what it will do. So it will just be something like that: 2, 3, 3, 2, 1, 5, and then 1, 1. So basically, I didn't even look at the left hand side, but you can see that it is similar to what we have here. So I think we have a general understanding of what we have to do, so we can go ahead and start coding this up. But sorry if I'm very slow with my coding, but I like to just take it step by step, so I just assume so that everybody can understand. But and I'm also learning myself, so that's how we can go about it. So basically, we know that our base case is when n equals 1. So sometimes when I'm thinking, I just type and delete stuff. So just bear with me, because I have not like pre-thought about the solution and just typing it out so you guys know. I think about it while I'm also um creating the video as well. So it's as natural and as genuine as I am thinking through the problem. So basically, we know that when we have this, we can probably keep our base case equals um base case equals um base case equals let me just say base case equals 1, and then we know that um for I in range, because we need to start from 1 to n plus 1. So so we can just say for I in range I to n plus 1. So because we need to n plus 1 to just get to the nth element. So for I in range I to n plus 1, we know we're always going to keep a dictionary, and our dictionary will just be stored as this, because we always need to store whatever we're going to be putting through at every point. So what we do is we so actually we don't even need to start from 1. We just need to start from 2, because we already know what 1 would give. 1 would give us the base case of 1. So we just need to start from 2. So we just say starts from 2 to n plus 1. So we know 2 would be the base case. So we just start to push things into the dictionary. So we look at whatever we have in our base case, or we can even just say start, not to let it look like base case. So we can just say start equals 1. And so we can just now look at it like for car, or should I just say car? For for oh no, yeah, for car character in start. Right now we're just gonna do dictionary character equals get uh character zero. That means if not saying for put a zero, and then it's just this is a dictionary method that just increments just to keep a counter. So it just keeps a counter of it. So it just keeps the number of times it has seen it. And then now that we have that, all we have to now do is now at least we have through the dictionary what it's supposed to be. So what we do now is we go through the we go through the character again. So um now we have as like scene set, which is supposed to be equal to like a set, so that it makes sure we don't repeat something again just for the sake of it. And then so so we just go through the start again. So now we just go for character and start again. So we do it again. So if character, because if we've already seen you, we push you into the set. So if the character is if character um uh how do I say if it's not in scene? So if character oh okay. So if character in scene, we just continue. Else that means it's not in scene. Yeah, or I think we can just do not in. Oh, I don't know, but I'm not actually sure. But I'll just do if characters in scene, just continue. But if it's not in scene, what we can do is we can create our let's say our result to be equal to this. So what we can say is if character is not in scene, what we can do is what we can do now is we can just check. So we can say results plus or equal to, so now results will be appended of the, we start with a value and the key. So string of um okay, so I think each one of them will be in the dictionary. So string of date of character um plus um plus character itself. So this would be it. So results would be this plus this. So this is what is going to go on. So by the time we're done, we're just going to have results, and then we can just say results should be equal to, oh no, we can just say um start should be equal to results, so that we keep it through it and then it gets done every single time. But so 1 2 1 1, yeah. So it should be like this, and then in the end, we return start. So maybe there'll be some errors and stuff, but at least I just like to run through it to see what's going on. But yeah. Oh, I think I forgot something. But yeah, beside that, we just need to make sure that if it's not in scene, after we do this, we need to add this to scene. So scene dot add um car. So it adds it so that next time, if not, it won't be able to see it. So that's what we do. Now let's run it again to see what goes on. And then like I think they gave some test cases. So let's use example test cases just to see what goes on. Probably be some errors, but see. Okay, it works pretty well. That's not bad. Let's try some on our own. Like I said it's always gonna be from 1 to 30, so let's try like 9. It'll probably be slow, but I guess that's how we have to go about it. So like I see a faster route. Okay, so apparently for 9 we're wrong. And why is that so? We are wrong because Apparently, they want it to be. We have 4, 2, 3, 1, 1. Okay, which means that there are probably going to be some mistakes here. To know this, let's see what 8 is. Mhm. So that means there's a mistake coming from somewhere. 4 seemed fine. Let's see what 5 says. Yes, so for 4, that seemed fine. 5 seems to be a problem. So for each of them here, we just need to print results just to see. Yeah, let's for each of them before we go to the next one. Yeah, let's just print start just to see what is going on. But yeah, it seems there's an issue. So there's 1 1, there is 2 1, there is 1 2 1 1. Then for the fifth one, it says 3 1 1 2 rather than that. But if 1 2 1 1, what it means is it should see um oh, so it should be 3 1s and 1 2s as it's saying here. But oh, so they want it to be like 1 1 1 2s. Okay, so they want it to be 1 1 1 2s and then 2 1s. Okay, okay, that makes sense then. Which means that basically all that means is that as we're going through the character, that just makes sense then. This is not hard. So basically, all that means is that as we're going through the character, I didn't understand it that way. I think probably that's more of the reason why people graded it down, but or had like a very low like. But I think then all we have to then do is that rather than just put it in this way, for character in start, um, all we have to do is if we see a different character from it, we have to yeah, we can't just say 3 1s or something. We have to actually then stop and then count it out till we see the next character. That's basically all they want us to do then. So yeah, but this was probably still hold, but that means that this scene sets will probably not be useful anymore. But what needs to happen is it needs to count the number of times it is seen it. Yeah, that just that's all that just needs to be done. But yeah, so basically this is just like a different change now. So basically we just have to rather than even now keeping a dictionary, we can just keep a counter of we can just keep a counter. So we can just keep we can just keep a counter. So counter we can just keep a counter which is just 0. And then for character in starts, all we just have to do is if character um um for character in start we just have to keep we just have to keep um current to be equal to start no, yeah, to be start 0 to be the first character. So all we just say is for character and start if car equals current counter plus or equal to 1. That way it keeps a counter. So if elif car is not equal to current, if it's not equal to current that we're looking at, all we just have to do is yes, so now we keep our results here. Results will be equal to here, so we just clean these two up. So if it's not equal to the current, all we just have to do is that results plus or plus or equal to the counter, so string counter plus current. So it keeps it this way. So results plus or equal to that counter will be equal to 1, and then current will be equal to character. So basically, if this is not equal to it, then this should happen. And so this will basically just keep updating it this way. And then in the end, when it's done, so start will be equal to results in the end. And then we can print start and we can see what happens. Hopefully there'll probably be still errors, but let's just see. Oh yeah, in the string outer range. What the heck? Um, hold on. Uh, hold on. Um, why is it this way? Should be. Why am I even going? Yeah, that should work. Why is it not working? It should be start 0 for character and start if character equals current. Why is it saying it's out of range? This is not out of range. Start 0. Every one of them would at least have one. Yes. Oh. Oh, okay. What if it's the last one and it's not? Makes sense. Results equals character. But then in the end, if it goes stored or results plus or equal to str counter plus current. Yes, this should work. Should work. Yeah. So 5 should work now. That makes sense now. So sorry guys, but like as I said, I go through this with you guys, so this should work now. So 9 should work now. Probably will be the slowest, but it should work. So yes, it is taking a while, as we can all see that, but now they told us 30. If it works for 30, it should probably work for all of them. That should be the worst case. So I'm very sorry guys. I go through this with you guys. So I know it takes a while and stuff, but that's it. Yeah, runtime this should work. So this is perfect. Let's at least set this back on our base case to make sure it works. Because if it doesn't work for your base case, it's a bummer. Yeah, now we can submit. Yeah, and there we go. And 99%. But that is pretty fast, pretty efficient, as it's not using much space as I thought it would be, and everything is perfect. But let me know which other ones you want me to work on, and I will do exactly that. And thank you guys.